Alright guys, so real quick I just want to talk about chapter 2.5, Compound Inequalities. And really I just want to do a few problems. If you can, remember that there are two types of compound inequalities. It's really just two inequalities set up into two types of problems. There are AND problems and there are OR problems. So we have two types of inequalities, two inequalities joined by either the words AND or OR. If I'm asking you to solve an AND problem, then really I'm asking you what intervals or interval satisfies both inequalities at the same time. If I'm asking you to solve an OR problem, then I'm really asking you to find what interval or intervals satisfy one inequality or the other. And so the official terms that we use for AND problems are to find the intersection, find the overlap of the two sets from each inequality, sorry. Whereas OR problems, we're really telling you to find the union, or union the two together. So all I mean when I say this is that there are two types of inequalities. I might ask you to solve something like x is less than 5 and x is greater than or equal to -2. Let me point out that my writing is first time writing on this pad, so bear with me. But again, notice that this is an AND problem. You want to find the numbers that are less than 5 and greater than or equal to -2. Whereas if I just change the problem up a little bit, I say take x less than 2 or x greater than 5, then the problem is completely different. I don't want the numbers that are less than 2 and greater than 5. I just want the numbers that are less than 2 or greater than 5. And so there are a lot of numbers that do that. There's -1, 0, 1, 1.5, 1.9, 1.99, all the numbers less than 2. And then all the numbers greater than 5, 6, 7, 8, 9, 10, so on, they satisfy one or the other. Whereas there's only a handful of numbers that satisfy the AND problems. I mean, there are still infinitely many, but it is a smaller range, meaning the numbers that are less than 5 and greater than -2 are, well, of course, -2 satisfies both. 3, 4, 5 doesn't work, but 4.9 does, 4.99 does. There are still infinitely many values here that satisfy both. But the key word is the fact that it's AND versus OR. Okay, and so we're going to focus mostly on OR problems in this video. I just want to, again, show you the difference between AND versus OR. So let's do a bunch of OR problems. We'll talk about AND problems. I think they're a little bit more intuitive. You're just looking for the intersection of those two sets. The numbers that are less than 5 and greater than or equal to -2 are all those numbers between those two. But the OR problems, I'll show you all the special cases. Those can be a little bit more tricky in my mind. So let me just start off with the fact that these are already going to be solved. I just want to show you some special cases. Solving them is no problem. Like if I said to solve 3x plus 1 less than or equal to, say, -5, or 2x minus 1 greater than 5. You know, I have complete faith that you'll be able to solve these, right? You just subtract 1 on the left so that 3x is less than or equal to -6. Divide both sides by 3 so that x is less than or equal to -2. On the right, I should add the 1 over so that 2x is greater than 6, and divide both sides by 2 so that x is greater than 3. The point is, though, that this is an OR problem, and so for the rest of the video I'm just going to give you a bunch of intervals like this. I want the numbers that are less than -2 or greater than 3. And I want you to think about which numbers satisfy one inequality or the other. Well, if you put it that way, the numbers that satisfy one inequality or the other are all the numbers less than or equal to -2, or all the numbers greater than 3. What that looks like on the number line is well, I guess first a bracket at -2 opening to the left, right? Those are all the numbers less than or equal to 2. All the numbers greater than 3, that's a parenthesis going in this direction. Those are all of the numbers that satisfy one or the other. It's basically two disjoint intervals union together. I'm unioning these together, so I have to take the interval from -infinity to -2 with a bracket, and then union that with the interval from 3 to infinity. So if they're two disjoint intervals going in opposite directions, I think that's usually the nicest OR case. But I want to go into some of the special cases. Again, one way to check these problems is to test the value in here, like maybe plug in -3 into the original, make sure it works. Maybe plug in 4 in the interval, plug 4 into the original on the right, and make sure that one works. But take something in the center, like 0, and make sure it doesn't work in either of them. The point is, all of these numbers will work in one interval or the other. They could potentially work in both, but they don't have to, right? Because that's the point. It's one interval or the other. This is an OR problem. This is a OR compound inequality. But what if I had something like, say, x is less than or equal to -4, or x is less than 0. This, I think, really will show you the difference between AND or problems. Let me draw my number line. Sorry, bear with me. I'm getting the hang of it. The numbers that are less than or equal to 4 or less than 0 are just the numbers that are less than 0, right? Again, the values have to satisfy one inequality or the other. The numbers that are less than 4 are less than or equal to 4, -4, -5, -6, and everything in between, right? All the way on to -infinity. The numbers that are less than 0 are -1, -2, -3, -4, -5, -6, and so on. So there is a little bit of overlap. There are some numbers that satisfy both, but I just want the numbers that satisfy one or the other. So all the numbers that are less than 0 or less than negative 4 are really all the numbers that are less than 0. Think about it this way. If I did the numbers that are less than negative 4, less than or equal to negative 4 in red, well, that's a bracket going in this direction. And if I take in green all the numbers that are less than 0, that's a parenthesis. Sorry. That's a parenthesis at 0, also going in this direction. Again, these are two intervals, but what happens is I want to union them. I want to combine them into one interval. So if I ask you which numbers are less than 0 or less than or equal to negative 4, looking at this picture underneath, I have that, yeah, there's a little bit of overlap, but really all the ones in green cover one or the other. So really all I need is the numbers that are less than 0 to cover both cases. They satisfy one or the other. Let me just mention though that I wouldn't draw these graphs underneath. I'm just using them to show you the difference between, or show you the reason behind why I'm choosing the numbers that are less than 0 to satisfy both graphically. Maybe you can see it right away without the pictures. That's totally fine. If it's confusing you, forget it. The numbers that are less than 0 or less than or equal to negative 4 are just all the numbers less than 0. Fine. So then my answer, my solution set in interval notation, is all the numbers from negative infinity. Sorry, let me change my color here. They're all the numbers from negative infinity to 0, and that's it. It's just one single interval because the two have been unioned together. If I do something similar, maybe say, let's look at the values. Let's take the OR problem. X is greater than negative 3. Let's do greater than or equal to negative 3. Or X is greater than 1. And let me get my number line drawn while you think about that. Think about which numbers are greater than or equal to negative 3 or greater than 1. Again, this is an OR problem. The interval, the solution set just has to satisfy one or the other. I have two inequalities. I need the numbers that satisfy one or the other. So which numbers are greater than negative 3 or greater than 1? Sorry, greater than or equal to negative 3 or just greater than negative 1. Technically, that's all the numbers greater than or equal to negative 3. Again, if I do something similar with the colors, the numbers that are greater than or equal to negative 3 are a bracket going in this direction. All the numbers that are greater than 1, that's a parenthesis going in the other direction. So I'll do that in green. All the numbers greater than 1 is a parenthesis going in the same direction. Sorry. Again, I'm saying which intervals on the number line satisfy one inequality or the other. Well, the red one covers everything that the green covers, so it satisfies one or the other on its own. The green one's kind of redundant. So that's why all the numbers that are greater than or equal to negative 3 or greater than 1 are just the numbers greater than or equal to negative 3. If you union these two graphs together, you get this single graph on top. Notice I'm not drawing another parenthesis on top or anything like that. They're becoming one single graph, and since this is an OR problem, the bigger one takes over. So then this becomes the interval from negative 3 to infinity. Sorry, I put it in green. Let me undo that. And like I said before, one way that I like to determine which numbers work is the pick a number game. If I asked you to pick a number greater than or equal to negative 3 or greater than 1, then you have some choices. All the numbers greater than 1 work, all the numbers greater than or equal to negative 3 work. So one person might say, oh, choose 2, choose 3, choose 4, choose 5. Great. Another person might say choose -2, -1, 0. But then they say, oh, but you could also choose 1, 2, 3, 4, 5 again. So there's some overlap here, as you can see from the graph, but the numbers that satisfy one or the other are all of these. The last real special case that we need to worry about is what happens if I have something like x is greater than 0. Sorry. X is greater than 0, or x is less than or equal to, say, 2. Again, maybe I ask you to pick a number greater than 0 or less than 2. Think about it for a second. The numbers that are greater than 0, that's everything to the right of 0. The numbers that are less than 2 are all the numbers to the left of 2. So this time there's some overlap, and I just need some numbers that satisfy one or the other. Well, all the numbers that satisfy 0 are 1, 2, 3, 4, 5, all the positive numbers, right? All the numbers that are less than 2 are some positive numbers, but also all the negatives. So really every number on the entire number line is going to satisfy one or the other. Try to think about a number that wouldn't work. There isn't one. Any number you pick is either going to be less than or equal to 2 or greater than 0. So what that means is that our solution set is the entire real number line. If you're still not seeing it, then let me draw the graphs in colors again. Again, I'm just doing this to show you it visually. The numbers that are greater than 0, whoa, got carried away there. The numbers that are greater than 0, that's a parenthesis going in this direction. I'll do it in red. But in green, the numbers that are less than or equal to 2, that's a bracket at 2 going in this direction. And if you're thinking about an AND problem, there is some overlap, there is an intersection that you might want to take, but that's not the type of problem that we're dealing with. We're dealing with an OR problem. This is an OR problem. You got to union the two. The two graphs are being unioned together. So all the numbers that are greater than 0 are everything in red. All the numbers that are less than or equal to 2 are all the things in green. When I combine them, they cover the entire real number line. So that's why I have this graph up top that just covers everything. That solution set is the interval from -infinity to infinity. That's no better. Maybe I should give out bonus points for not making fun of my handwriting in these videos. Then I guess I'd have to give bonus points for not making fun of my handwriting in real life. Anyway, the interval is the entire real number line. It is all of the numbers from -infinity to infinity. So that's kind of the last special case. If you want some good practice, I recommend kind of going back through the same examples that we just looked at. Take x is greater than or equal to -3, or x is greater than 1. Take x is less than or equal to -4, or x is less than 0. Take 3x plus 1 less than or equal to -5, or 2x minus 1 is greater than 5, and just change them all to AND problems. So go through all these problems and change them to AND problems. If you get a chance before Tuesday and you want me to look at them before class, just bring it up and say, hey, did I get these ones right? And I'll be glad to look at them. But I think it's a good idea to just keep the numbers the same and change them to AND problems. Look at the intersection between these two graphs instead of unioning the two graphs. See what you think should happen, and then on Tuesday we'll clarify everything. All right, so there's a problem on Math Excel. You can try it for an extra credit quiz point. If you get it correct, then I'll add it to your quiz scores at the end, but it's best to just let them add up and then have have a better quiz scores throughout the semester. All right, if you have any questions, email me. Otherwise, I will see you guys on Tuesday.